Okay, so your key problem here is you're not doing the problem. Okay, and there's a couple of little things, but you all right. So the first thing, the problem asks you to locate and find, or whatever, I don't know, the critical points. Okay, the issue here is you have copied down the equation perfectly. Here's your equation that you're supposed to be using to locate and find your critical points. Then you did your first derivative and of with respect to x and first derivative with respect to y perfectly. But then what are you supposed to do with them? You're supposed to set these equal to 0 and you're supposed to solve, and you're supposed to use these to find your x and your y values. And this is one of your issues. Where did these numbers come from? Well, what you did is you just pulled them out of the problem. You said, these are the answers. This is what the problem tipped me off to. That's not how you're supposed to be doing these problems. You need to set them equal to 0. You need to solve. You need to figure out which ones of these from the problem are actually critical points. One of these is not a critical point. So when you do your algebra, maybe it's the 0, 0. I don't remember. So if it's the 0, 0, you'll say, okay, my algebra, I did the work. I did not get x equals 0 and y equals 0 as an answer. So this thing, I don't need to use the d-test. It's not a critical point. I don't need to test what it is. It is not a min. It is not a max. It is not a saddle because it is not an extremum. It is not a critical value. So the first thing you have to do is you have to solve the problem like we did in class. Solve the problem like we did in the notes, okay? Then determine of the ones that actually came out, then use the d-test to figure out what they are. Now, maybe that one, I don't know if that one is or is not the max or min. The next thing I want to point out. All right, let's just pretend. Let's pretend all three of these actually are extremum. Okay. What I told you guys in class is I said, remember, the d-test, the Haitian test, only works if your answer is not equal to 0. If your answer equals 0 like this one does, if it ends up where d is equal to 0, you have to use another test. Okay, so therefore, what test do we have? Well, you can use the 3D graphing software, you can plot the points, you can do something just to figure out if that thing is a max or a min or a saddle. So, but you know, when you use the 3D graphing software, just look for 0, 0 and see what you see there. Now, I promise you, I will not do that to you on the test. Okay, when you're doing pen and paper test, it will never be equal to 0. So just because you have a 0 here doesn't necessarily mean it's going to equal 0, because you could have a value here, right? So if you had like a 4, then you'd have 0 minus 16, which would give you negative 16, which would tell you it's a saddle. So therefore, so the idea here is when you have a 0, use another test. This is not enough. This won't work with the Haitian test. Now, for this next one, you see we have a positive number. And as we talked about, anytime you get a positive number, it's either a min or a max. So what we're going to do is we're going to look at the second derivatives. These are positive numbers. A positive second derivative talks about concave up, right? Happy face, positive. So if it's concave up, is this thing a max? No, 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 no. That's a min. So therefore, this is a min. So you have the right idea. You recognize that this is a positive answer, so therefore it is either a min or a max, and you have to look back at your second derivatives to figure out which one it is. Finally, when you have a negative answer, that is a saddle every single time. So whenever your d-test or Haitian test gives you a negative number, it's always a saddle. So that one looks good. Okay, I hope that cleared up whatever your issues may have been.